In this lesson, we're going to review graphing in slope-intercept form. So our essential question here is, how do we use slope and y-intercept? How do we use slope and y-intercept to graph a linear equation? How do we use slope and y-intercept to graph a linear equation? Okay, so on a lot of this, what I'd like you to do is use a highlighter, highlight some things, make some side notes, and then when we come to class, we're going to actually practice graphing some of these. So the first thing that's important to make sure is that our equation is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. The m stands for our slope, the b stands for our y-intercept. And it's really important to remember slope means rise over run, or the change in the y and the change in x. And that b, the y-intercept, is where the graph intersects the y-axis. One thing that I want you to write as a side note is that if we have a positive slope, when I ask you to move using the slope and create new points, I always want you to go up and right to begin with to get your graph going. If your slope is negative, I want you to go down and right. Notice every time I'm asking you to go right to begin with. This just helps us get our graph going. We have to make less decisions on which way to move. So looking at the example, the first example, we need to make sure that our equation is in slope-intercept form. It is already in slope-intercept form. So the next thing we need to do is identify our slope and y-intercept. And so you can see right here that they have identified our slope and y-intercept. So always make sure that it's in y equals form, our slope-intercept form. And so now to graph this, once we've identified our slope and y-intercept, and I like this little note here where it says m is married to the x for our slope, we're going to begin with b. We're going to begin with the y-intercept. Our y-intercept was positive 2, and so that's why we have put our first point here at positive 2. Our slope is 3/5. It's a positive slope, so notice it says you're going to move up 3 and right 5. So from my y-intercept that I already drew, I'm going to go up 3 and right 5, and I'm going to put a new point. Once I draw up one point to the right and maybe a couple of more, I can go back to my y-intercept and I can reverse my steps. I can go down 3 and left 5. 1, 2, 3, 4, 5, because we already know which way our graph is going. And then at that point, I would connect my points. Remember, we know that a positive slope should always rise to the right. And so that is another way to check yourself to make sure you've graphed it correctly. Looking at the next example, you'll notice that this equation is not in slope-intercept form. And so in order to get this in slope-intercept form, we first have to move the 8x to the other side. Since it's a positive 8x, you see that we are subtracting it from both sides. When we move a whole term, we move it by adding or subtracting. Once we do that, the y is left with a 4, and since we just want to cancel out the 4, we're going to divide both sides by 4. And so that's why you see this division step. And so that would leave us with an equation y equals 3 minus 2x. Now if you truly want to put it in slope-intercept form, you can switch it around, keeping that negative sign in front of the 2x, and that makes it a little clearer to see. No matter where it is, that slope is still married to the x, and so our slope is negative 2. I want you to notice that negative 2 is not a fraction to begin with, and so to help us when we graph, we went ahead and put it over 1 to make it a fraction. And then our y-intercept is 3. Okay, so to graph this, again, we always begin with b. So in this case, our y-intercept was positive 3, so that's my first point. And then our slope was negative 2, or negative 2 over 1. So just like I said, if it's a negative slope, we're going to go down 2 and right 1 in this case. So from my first point, down 2, right 1, and put a point. And I can do it again. Down 2, right 1. And I could keep going as many times as I wanted so that I had a nice looking graph. I could also reverse my steps and go up 2, left 1, and then connect my points. The more points you draw, the better graph you're going to have. Remember, we know that a negative slope graph should fall to the right. And so that's another way to check yourself to make sure that your graph is going in the correct direction.